Hi, I'm Alex Brown, and today I'm going to present my beautiful concept map on chemistry terms. As all of every day, we're going to start with atoms. Atoms are made up of electrons and the nucleus. The nucleus contains neutrons and protons. Protons are positive, neutrons are neutral, and electrons are negative. The electrons live in their electron shells, which surround the nucleus. And each shell can only hold a certain amount of electrons, like the first shell can only hold 2, the second shell can hold 8, so on and so forth. The valence electrons is the outermost electrons of any atom. Like on the hydrogen, it only has 1 electron, so that 1 electron is their valence electrons. This is what impacts electronegativity, which plays a huge role in bonding. And the amount of electrons play into how electronegative something is. Like carbon is one of the most electronegative molecules because it only has 4 electrons and it wants 8 in its outermost shell. And cohesion and adhesion is just the likelihood to bond with something that you like. Adhesion is likelihood to bond with something that you're not but you like with. Okay, and then covalent bonds is the major bond. It involves the sharing of electrons. There's polar and nonpolar covalent bonds. Polar is where you share the bonds unequally. So like a water molecule is polar. So the oxygen is more electronegative than the hydrogens. So it takes those 2 electrons just a little bit more than the hydrogen does. And that makes the oxygen slightly negative and the hydrogen slightly polar, or slightly positive. So they have poles. Nonpolar is when they're shared completely equally. And then there's double and triple bonds, which the double bond is when 2 electrons are shared between 2 atoms. And then a triple bond is where 3 electrons are shared between 2 atoms. And then there is the ionic bond. The ionic bond is when one atom completely gives up its electron to another. And the reason why they stick together is because of the opposite poles, or the opposite charges. One's positive and one will be negative, and opposites attract. So the ionic bond, you'll have an electron donor and electron acceptor. The electron donor is the one that gives up the electron, the acceptor is the one that takes it. And this causes cations and anions. Anions are negatively charged ions. And then cations are positively charged cations. And this normally happens in an oxidation reduction reaction. That's literally when 2 molecules react, or elements, and it ends in a positive and a negative ion. Oxidation is the positive and the reduction is the negative. Or the other way around. And then there's also hydrophobic reactions. It's just when unpolar molecules are considered hydrophobic, which means they don't like water. It literally means water. And they group together in the presence of water. Okay, and we'll come back to that a little bit later. And then back to atoms. Atoms make up elements, and the elements have atomic numbers and atomic numbers, which is the number of protons in each element. Atomic weight, which is the approximate weight. It's the average of the most common weights within the world, and that's normally the number of protons and neutrons. And it's measured in daltons. And then molecular weight is another way to measure the weight of an atom. To find that, you to multiply the atomic weight by Avogadro's number, which gives you moles. Moles are just, again, another way to measure how many molecules are in the. And then molarity is the number of moles per liter. You find that by dividing moles by the number of liters you have. And then liter, gram, milliliter, and meter are all different ways to measure things. And liter and milliliter are volume, gram is weight, and meter is length. Okay, and then back to elements. Okay, the four main elements in your body are nitrogen, oxygen, hydrogen, and carbon. And hydrogen and oxygen, as everybody knows, makes up water. Water has many isotopes, which are just different, like isotopes are elements or compounds that have a different number of neutrons than normal. So like if the hydrogen has no neutrons, then it's an isotope. And then isotopes could be radioactive, which means they're very unstable. And then that's how we find the half-life. Okay. And then hydrogen bonds are the reason that water has a lot of its special properties. Hydrogen bonds are the attraction between polar molecules. So it's like I was talking about earlier, where the hydrogen and the oxygen and two different water molecules are attracted to each other just because the opposites attract. And then hydrophobic interactions is what I was talking about earlier as well, that it's the attraction of nonpolar molecules in the presence of water. Sorry. And then hydrophobic, like I said earlier, means water curing. And then hydrogen tends to become an ion by gaining or losing an electron. Hydrogen ion. This is how pH is measured in solutions. Acids, which have a pH lower than 7, and which has a pH lower than 7, and have a higher amount of hydrogen ions in the solution. While acids have a pH lower than 7 and a higher amount of hydrogen ions. Bases have a pH higher than 7 and a lower amount of hydrogen ions. Examples of hydrophobic solution or molecules are lipids and methyl. Lipids are certain amino acids. That's an amino acid. Lipids make up phospholipids, which make up our cell membrane in our cells by creating a phospholipid bilayer. And lipids, phospholipids, glycolipids, which and then fatty acids, which are saturated and unsaturated fats. And then hydrogen helps create where'd it go? These two molecules, sulfidine, which is another amino acid. And amino acids are the building blocks to proteins, which serve many functions in the body. One of them is support and or structure, not support, my bad. And many other things. They're actually what give us our hair straight, or like whether our hair is straight or curly, and like everything. Glycoproteins is a form of amino acids, and then hydrogen is also one of the molecules, like I said, of hydroxyl, which helps make alcohol. And then carbon is is a huge element, or not huge, but it's an important element. It's the main focus of organic chemistry. Another branch of chemistry is inorganic chemistry, of course. And carbon is a component in carboxyl and carbonic. Carboxyl and carbonic, which are fatty acids, which I talked about earlier, make up saturated and unsaturated fats. Oxygen, carbon, and hydrogen all come together and make sugar, which is a carbohydrate, which is made out of monosaccharides, which make polysaccharides. And carbohydrates also help in creating nucleotides, and they join along with a phosphate group and a base to make nucleotides, which then and join together and create nucleic acids. And I believe that is all. That is my concept map of chemistry terms. I hope you enjoyed this video. Have a wonderful day.